Hi everybody. So the next chapter we're going to look at is chapter 6, and this will be about discrete probability distributions, where the probabilities come in sort of discrete pieces as opposed to continuous ones, which we'll talk about later. So the first section we're going to look at is section 6.1 on discrete random variables. So let's look at the objectives in this section. So we'll look at distinguishing between whether variables are discrete or continuous, so in other words whether the information comes in discrete pieces or chunks or whether it's sort of spread out continuously. We'll identify discrete probability distributions, construct probability histograms, compute and interpret the mean of a discrete random variable, interpret the mean of a discrete random variable, and compute the standard deviation of a discrete random variable. So let's look at objective 1. So the first thing we want to look at is being able to determine whether something is a discrete or a continuous variable. So a random variable is just a numerical measure of the outcome from a probability experiment. So again, it's random because it's like rolling a dice or something. You don't know exactly what you're going to get. You'll have sort of a range of values, right? Like if you're rolling a 6-sided dice, you only get like 1 through 6. So it's a value that's determined by chance, and random values are denoted using letters such as X. So a discrete random variable has either a finite or a countable number of values. The values of a discrete random variable can be plotted on a number line with spaces between each point. So like for example, a discrete random variable would be something if you roll a dice, right, you can either get 1, 2, 3, 4, 5, or 6. You can't get like 5 1/2 or 2 1/3 or something. You can't get every value between 1 and 6, so that makes it discrete. A continuous random variable has infinitely many values, or essentially infinitely many values. The variables of continuous random variable can be plotted in a line in uninterrupted fashion. So you might be talking about like snowfall here, like the amount in inches of snowfall. Now I guess in a way that's sort of discrete, because I guess snowflakes come in discrete quantities, right? You can't have like 2.5 snowflakes, I guess. But snowfall is usually measured in inches, which is a continuous variable, right? You can have anywhere between 0 and, I don't know, 100 inches if you're from where I'm from. So, that's the main difference between discrete and random variables, right? As discrete variables, you'll have distinct numbers or answers, right? 1, 2, 3, 4, 5. Whereas continuous random variables, you can have answers ranging from, like, say, everywhere between 0 and 5. Right, including fractions or square roots or numbers like pi or whatever. So let's look at some examples here and determine whether the following random variables are discrete or continuous. And let's look at stating the possible values for the random variable. So let's say you're talking about the number of light bulbs that burn out in a room of 10 light bulbs in the next year. Well, that would be discrete, right? Because either the light bulb is burnt out or it's not. You can't have like a light bulb that's sort of half burnt out, right, or something. So and then the numbers would be, anything from 0 light bulbs that burn out to all 10. B, the number of leaves on a random selected oak tree. Again, that would be discrete, right? Because again, there might be a lot of variables on a tree, but there's still, you could count them, right? So it's not like you could go from like 1 to 1.1 leaves or something, I guess, unless maybe if the next leaf is like really small or something. And then again, that would go from 0, 1 to 2 to whatever the maximum number is for the number of leaves on a oak tree. See the length of time between phone calls to a 911 center. Again, this would be more of a continuous variable, because you could say have a phone call and then the next phone call might arrive a minute later, and then the next phone call might arrive 2.5 minutes later, or 3.25 minutes later, right? You could have any number between 0 and some large number, right? I assume this is measured in 24-hour intervals or something, so maybe between 0 and 24, but we don't really know what the upper bound on the time is here, so we'll just say that the time is greater than 0. So there are some examples on talking about the distinguishing between discrete and random variables. So remember, discrete variables, sort of the information comes in chunks, and continuous, it's more fluid. Objective 2, identify discrete probability distribution. So remember, a probability distribution provides the positive values of a random variable x and their corresponding probabilities. Probability distribution can be in the form of a graph, table, or mathematical formula. right? Remember, you know, the probability distribution, the probabilities still have to add up to 1 and things like that. So, so X in this case represents the number of movies streamed on Netflix each month, right? So about 6% of people stream 0, 58% of people stream 1 movie a month, 22% 2 movies a month, etc. And this is a probability distribution, right? Because when you add up the probabilities, you get 1, and again, the probabilities are between 0 and 1, as we saw earlier in previous sections. So it is still a probability distribution. So the question is the following a probability distribution? Well, certainly all the probabilities are between 0 and 1. So the question is, if you add up the probabilities, do you get 1? Well, you don't in this case. If you add up all the numbers, you get 0.97 or 97%. It doesn't add up to 100%, so the answer to that is no. Is this a probability distribution? Well, no in this case, because one of the probabilities is negative, right? You can't have a negative probability in order to be a probability distribution. If you look at this one, so again, certainly all the numbers are between 0 and 1, so that's good. Now the question is, if you add these numbers together, do you get 1? In this case you do, so this would be a probability distribution. Okay, that brings us to objective 3. So objective 3 is to construct probability histograms. I don't know if I'm going to really have you guys do this. I might have you interpret these more than graph them, but a probability histogram is a histogram in which the horizontal axis corresponds to the value of the random variable, and the vertical axis represents the probability that the value, or probability of the value of the random variable. So let's look at an example here. So we'll go back to our Netflix example. So here's the number of movies people rent a month and the probability with which they rent them. So if this is a probability histogram, right, you'd have the number of movies on this axis, and then the probability that somebody would rent them, right? And so looking at this histogram, you can see pretty easily that most people only watch about 1 movie a month, or at least rent 1 movie a month. Okay, so that brings us to objective 4, which is on computing and interpreting the mean of a discrete random variable. So the mean of a discrete random variable given by mu sub x is basically the sum of what you get when you take the probability of occurring times the event that occurs. So x is the value of the random variable. So like for the last example, we would just multiply the x times the probability and then add the results together. So just to go back to that example, so basically you would just take 0 times 0.06, 1 times 0.58, 2 times 2.2, 3 times 0.10, etc., and just add those together. That gives you 1.49, and so that is the mean, or sort of the average of your random variable. So you can think of it as sort of a weighted variable there, or a weighted mean. So as far as interpreting this, the interpretation of the mean of a discrete random variable is, suppose there's an experiment repeated n independent times, and that the value of the random variable x is recorded. As the number of repetitions of the experiment increases, the mean value of the n trials will approach the mean, right, mu sub x. And so in other words, if you let x1 be the value of the random variable capital X after the first experiment, and x sub 2 be the value of the random variable x after the second experiment, you'll get this. And again, this should be dots here, dot, dot, dot. I don't know why there's an L thing there. And then the difference between x bar and x mu gets closer to 0 as n increases. So let's look at another example here to illustrate this. So the data in this table represents the number of DVDs rented by 100 randomly selected customers in a single visit. Compute the mean number of DVDs rented, right? So that means this person has rented 1 DVD, this person's rented 2, this person hasn't rented any, right? This person's rented 3, etc. So what you would do in this case is just take all those and add those up. So just take the the 1 plus 1 plus 1, plus 1 plus 1 plus 1 plus 2 plus 2 plus 2, just add all those up, and then divide by 100, and that gives you 1.49. Right? And then as the number of trials of the experiment increases, right, as you add more and more to there, right, the mean number of rentals approaches the mean of the probability distribution. Right? So you can see that if you add the first couple together, if you add 1 plus 1 plus 1 plus 1 and divide by 3 or 100, right, it's not very close to 1.49, but as you add more and more on there, that should happen. Okay, so let's look at the next objective here, which is to compute and interpret the mean of a discrete random variable. So because the mean of a random variable represents what we would expect to happen in the long run, it's also sometimes called the expected value, denoted by E of x of the random variable. Just to look at an example here, let's say that you have a life insurance policy that will pay the beneficiary a certain sum of money upon death of the policyholder, and let's say that these policies have premiums that have to be paid annually, and suppose that the life insurance company sells a $250,000 one-year term life insurance policy to a 49-year-old female for $53, right? So it's a one-year term, so it's only effective for a year. According to the National Vital Statistics Report, the probability the female will survive the year is 0.99791, right, based on her age and living habits. Compute the expected value of this policy to the insurance company, right? So, the insurance policy is out to make money, so hopefully it'll have a positive expected value for them. So, so if the person survives, right, then the insurance company gets the $530, right? And if the person dies, the insurance company has to pay out the amount, right, minus the $530 paid for the policy, and then the probability of survival is given by this. And then if you take 1 minus this number, this will give you the probability that the person dies, which should be pretty small. So again, if you compute this, right, take 530 times the expected value that the person will live, which is pretty high. So this is going to be close to 530. And then you add this value here, take this times this, and subtract it from that, right, because you've got a negative times a positive. That gives you a positive value of $7.50, right? So over the course of the year, right, on average, right, the insurance company can expect to make $750 or $7.50, right? So you can kind of think of that as what they would expect to make at the end of the year. Right now, obviously, everybody's situation is going to be a little bit different, but if they sell like a whole bunch of these policies on average, that's hopefully what they should bring in per policy. Okay, well, let's look at objective 6 here. So objective 6 is about computing the standard deviation of a discrete random variable. So we talked about computing the mean, so how do you measure the spread? Well, in this case, you can use this sort of complicated looking formula here, right? What we're doing is we're taking the mean, subtracting it from each data point, squaring it, and then taking times the probability, adding those together and taking the square root. Or what might be easier if you're computing it by hand is to use the second formula. It's equivalent to the first one. And there should be instructions in the step-by-step, technology step-by-step at the end of section 6.1, especially about how to do this on your TI-83. If you're this might be kind of hard to do in Excel, in StatCrunch. You can do it maybe a little bit more easily in Excel, but this might be something you might have to compute sort of by hand. But let's look at a quick example here. So let's say we want to compute the variance of the Netflix example we were looking at before, right? So we already calculated the mean, right? So take each data point and subtract that from the mean. So take this minus that, that minus that. Again, you'll notice some of these values will turn out to be negative, but you're going to square them. So square that, square that, square that. And then this is the probability, so take this times that to get that, and then finally just add all these numbers together. And then you would just take the square root of that. So if you add all these numbers together here, you should get that. And then finally take the square root, and that should give you 0.9327, right? So that's sort of a measure of how spread out the data is, right? It's still just the standard deviation, or I'm sorry, the variance in this case. Or, well, I guess this is the standard deviation, but just as we saw before. So, all right, well, so that should wrap up that section. So next, in the next section, 6.2, we'll look at what's known as the binomial probability distribution. And the only two sections that I assigned from this chapter were 6.1 and 6.2, and that's all you'll basically be responsible for. 6.3 and 6.4 are sort of optional sections, so you can do those if you want. And I think 6.4 is actually not in your book, so I think that's on the CD that comes with your book. So for those of you that purchased my Math Lab access, you may not have that anyway. So anyway, like usual, if you guys have questions or anything, just let me know.